I am Dr. Ketan Patankar. I am Assistant Professor in Physics, the Department of Physics, Rajaram College, Kolhapur. I am going to teach you mathematical physics. This is a topic which is very fundamental to learn in depth mathematical physics. So, this topic, the name of the topic is scalars and vectors. This topic is common to both BSc physics and astrophysics students. So in BSc first year physics students, this topic is allotted in paper one unit paper one and unit one, and for astrophysics students it is allotted in paper two mathematical physics unit one. So this will be a common this will be a common topic I'll be sharing with both physics and astrophysics students, that too PAMS group in particular. Now, let us begin with the very fundamental subunit of mathematical physics, that is scalars and vectors. So, to know what is a scalar? A scalar is a physical quantity which is described only by magnitude. We are going to discuss this in detail. Then afterwards, we are going to discuss what is a vector also. But see, then before that, we should know what is a physical quantity. All quantities which are measured in physics are called as physical quantities. So that which is measurable is a quantity, and that quantities which are measured in physics are called as physical quantities. For example, pressure, force, uh, velocity, acceleration, heat energy, intensity of sound. All these are the quantities which are measured in physics and they are called as physical quantities. And physical quantities are classified into two types. One is scalar and the other one is vector. So before learning vector, we should know what is a scalar. Next slide. Now look at this slide. What is that you are seeing is a car, a picture of a car. Now suppose something we are going to measure, we are going to make some measurements on this car. So then suppose I'm interested in measuring the length of the car. So it is already given on the slide that the length of the car is 4.5 meter. Now what is length here? Now length is a physical quantity or a quantity which is measured in physics, therefore it is called as physical quantity, and it is measured as 4.5 meter. You are measuring this length as 4.5 meter. You know how to measure the length. You can take a tape and you can measure the length of the car. So it is 4.5 meter. Look at this value particularly. This 4.5 is a value and it is having an unit. It is expressed in some unit. This is meter is its unit. So the length is measured in a unit called as meter. So this becomes the magnitude, or the value which is assigned to a physical quantity is known as magnitude. Now look at this physical quantity, that is another physical quantity I'm going to introduce to you, that is mass. What is that you're seeing in the picture? You're seeing a gold bar or gold biscuits. Everybody is fond of purchasing such type of gold biscuits and or gold bars. Okay. Now what is the physical quantity? The physical quantity is here is mass, and what is the value assigned to it? It is 1 kg, or it is measured, this one gold biscuit weighs 1 kg in mass. So this 1 kg, that is the value along with the unit, becomes its magnitude, and scalar quantities are only described with their magnitude. Okay, is that clear? So this is mass is a physical quantity. Next, we are going to discuss, this is something which you normally come across when if you are involved in some sport activities. This is a timer, okay, and some of you may be having a wristwatch, a digital wristwatch. A display panel on that digital wristwatch shows this type of reading. Okay, then what is the time now here? The time is shown as 12.76 seconds. So 12.76 becomes a magnitude and time is a physical quantity. Is that clear? So then what I want to say is this 12.76 is a physical quantity, is a magnitude, and this time is the physical quantity. So this time doesn't need any direction or the it see it's, what is the time, you just say only 12.7, you never mention the direction over there. So the scalar quantities are described only by their magnitudes. Next slide. See, in this corona pandemic, everybody is very worried about the body temperature. What is the temperature shown on this by this thermometer? It is 36.8 degrees Celsius. So temperature is again a measurable quantity, and therefore it is called as physical quantity. And just see what is the magnitude assigned to this physical quantity is 36.8 degrees Celsius, because this thermometer is reading at 36.8 degrees Celsius. So understood now what is the physical quantity and what is the magnitude. So first we have discussed length, then mass, then time, then we are discussing the temperature. Now we are going to tell what is a scalar. Scalar is a physical quantity that has only magnitude. So I'm just listing all those fundamental units, that is mass, length and time, on the left hand side of this left hand side of the list of the examples, and temperature, volume and density on the right hand side. See, in fact, mass, length and time are called as very much basic or fundamental quantities. Why they're called as there is nothing which is more fundamental than this. The other quantities in physics are called as derived quantities, because they are derived from these physical quantities, that is mass, length and time. Temperature is also nowadays added to this fundamental unit, because in SI unit, along with mass, length and time, we are mentioning temperature, we are also mentioning intensity of light, and we are also measuring quantity of electricity, that is current. So ampere, Kelvin, and even what can say, candela are added to fundamental units like kilogram, meter and second. So this is what I want to say, even if I put it on this side, but even this goes as a fundamental unit only. But volume is a derived quantity. Why? Because length into L into L into L means length into length into length, or the breadth, you can consider it as a, what is measured in the breadth is itself the length, is the fundamental quantity measured is length. So L into L into L is nothing but volume, means 3 times L is the volume, means what the volume is not a fundamental quantity, it is a derived quantity. Density also is a derived quantity, because density is equal to mass upon volume. So understood the difference between the fundamental quantities and the derived quantities. And scalar is a quantity, physical quantity, which is having only magnitude. So both derived quantities or fundamental quantities are definitely, like mass, length and time, are definitely scalar quantities, but derived quantities are also can be a scalar quantity, or derived quantities can also be vector quantities. Okay, next we are going to move to the next slide. Then now let us come to the what can say, very important quantity, that is which we require. And vector algebra, the chapter vector algebra depends upon what is to know depends upon this fundamental quantity, that is vector. So what is a vector? Vector is a physical quantity which requires both magnitude and direction for its complete specification. Now, how to understand that, why we should require both magnitude and direction? So previously when we are discussing mass, length and time, only the magnitude was sufficient to describe that quantity. But here now just see, I'm interested in, see, this is the, I think, a map of America, and here is California, and here is North Carolina. I just want to know, I'm interested to know the position of California from North Carolina. So see where it is positioned means what, and how far it is from North Carolina. Both are important to me. So if I measure the magnitude, then it is from North Carolina. The distance between North Carolina and California is 3,600 kilometers. Okay, so this describes you the magnitude, but that doesn't give you the complete idea about the position of California from North Carolina, whether California is towards the east of North Carolina, or towards north, or towards south, or towards west. But the thing is, if you just look at this picture, it is towards its west. So position is completely specified by knowing uh, the distance of the North Carolina from North Carolina from California, and also it is specified with the help of direction, that is it is towards its west. Okay, so this is what is since the position can is completely specified by knowing it, the distance of California from North Carolina, that is magnitude, and also it's because it is towards its west. This is taken as reference here, so the distance is measured from here, and it is towards its west. Now, so direction has come into picture. So a vector quantity which requires both magnitude and direction for its complete specification is understood in terms of noting the position. Next quantity, we'll just look into this next quantity. Now suppose from USA you are displacing an object towards China. So what is displacement? Is it is the minimum distance taken by the object to move itself from USA to China. So now this is a displacement, but the displacement, if you just measure the minimum distance, you are getting the idea about magnitude. What should be the distance to be traveled from minimum distance to be traveled from USA to reach China. But the direction also is important, as told you, when you are displacing an object from USA to China. So you are going to displace it towards the east or north or south or west. But the thing is, here it is very clear that you are going to displace it from USA to China, means towards from USA means, and towards China means in the east direction. So direction also is important when you are considering a displacement, that is a measurable quantity, that is physical quantity. So displacement becomes a vector quantity. So vector is a physical quantity that has both a magnitude and direction, that is position, displacement, velocity, acceleration, momentum, and force. Is that clear? Now, these are the different physical quantities. Usually, you come across this type of physical quantities in mechanics. So they are different again, different types of quantities like magnetic field intensity. There are different branches in physics. So all those magnetic field intensity, whether it is a vector or scalar, any quantity henceforth which is when it is introduced to you, the first question you are going to ask me whether it is a scalar or a vector. Once this is clear, then the mathematics to be applied to this physical quantities, or say what say physical quantities, when you are, why you measure physical quantities, because they have some applications in some areas, or in some areas like means you can say that it may be having a engineering application, or it may be very important in developing a technology, right? So when that, then the only simply measurements doesn't is not is of no what you can say is suppose if you are measuring a physical quantity and leaving it to itself, then it is of no use. So you are going to measure it, and you are going to try to apply that measured quantity in some or other applied areas. Okay, areas of applications. So then where you are when you see, then when the measured quantity, it has to be mathematically analyzed, and therefore the vector algebra comes into picture over there, right? So then the thing is, you have to basically understand what is a vector. Then you have to you should understand the rules which govern the vector algebra and all. So that's why this chapter is introduced at BSc part 1 level itself. Next, very important is, after you measure, if you know, now you are familiar with what is a vector. Vector is represented by, so vector is required to be represented. So it has both magnitude and direction. So the both the quantities, how they are been represented. See, magnitude of any vector is represented by a line segment. For example, if I am having a 4 Newton force, if I take a line segment of 4 centimeter, means 1 centimeter represents 1 Newton. So second centimeters represents 2 Newtons. If I just traverse forward, and if I say it is 3 centimeters, then it is 3 Newton. If I traverse 1 more centimeter forward, it is 4 centimeters, means 4 Newtons. So the length of the line represents the magnitude of the vector, and the angle over here means the angle also is measured with respect to certain axis. Suppose if I choose for sake of convenience x-axis of the Cartesian coordinate system, then that is taken as a reference axis, and the angle made by the actual vector, that is length of that vector, or length or line segment of that vector, which is representing its magnitude, is another line, and the axis is one line. So the angle between them is measured in terms of measured in degrees, and that gives you an idea about how where is this vector pointing, in which direction it is pointing. The angle itself will specify the direction of this vector. So representation of vector means the representation of its magnitude and direction. Magnitude is represented by the line segment, and angle represents the direction. So the angle is the angle between the length or line segment representing the vector and the usual, and the reference line here over here is x-axis. Now, representation of the vectors are usually represented by single capital alphabet with an arrowhead over it. So anywhere in any physics textbook, if you just come across an arrowhead on a letter which is representing it, then it is a vector quantity. Otherwise it is a scalar, simply scalar. If a bold letter is there, then also it is a vector quantity. If an arrowhead is there on the letter representing then it is a vector quantity. So there are some alphabets which are reserved for physical quantities. Suppose capital F is used for representing force vector. Now capital P is representing pressure vector. V represents velocity vector. So there are different types of notations, and some symbols are reserved internationally for representing some particular vector quantities. Okay, then that is internationally accepted. Now small letter a is representing a position vector. So there are some alphabets reserved for representing a particular type of vector. This is also important. Now see here. This is what what I was telling you. This is R is a position vector, V is a velocity vector, and F is the force vector. Now in next class we will study what is we'll study